Good morning, Falcons. It is an absolutely fabulous day to learn some geometry, and it's going to be even more amazing because with a growth mindset, you're going to try hard because we're working on triangles. So, a triangle is a polygon. Polygon just means like a closed figure, straight lines, that kind of stuff. A polygon with three sides and three angles. When we name triangles, we name them using the three vertices or the 3 points. Vertices is just the plural of vertex. So this triangle, we would name it as triangle, oops, that looked ugly. Triangle ABC. Or we could name it as BAC, CAB, CBA, whatever. The order doesn't matter. It's kind of like planes, if you remember naming planes. What is important, though, is that if we are comparing this triangle to a triangle that's similar to it, then the order would matter there. But what I'm about to write down next doesn't need to be written down in your notes. It's just something to keep in mind. So there are a few ways to classify triangles that you might actually remember from elementary school. So one way is to classify a triangle by sides. So with three sides of a triangle, it could either have all three sides the same length, in which we call that an equilateral triangle. And that would look something like this. And what we could do is just add those little tick marks to the three sides to know that those three sides are equal. It could also mean we could have a triangle. Another way is two sides with the same length and the third one wouldn't. And these triangles are called isosceles. So this might look something like, that's not what I wanted. I don't like that. Or that one. I'm trying hard. That one looks a little bit more like an equilateral, but maybe I will see if I can. There we go. That's an isosceles triangle because the two sides that we have as looking congruent for us would be these two. And that bottom one isn't the same side. And then there's also a third type where there's none with the same length. And those are just called scalene. So those might look something like that. There's also ways we can classify triangles by their angles. So similar to the sides, we could have three of the same angles, which we just call equiangular. So we can mark that on this equilateral triangle because those would all have the same angles. We could have an acute triangle where all of the angles are acute. So maybe something like this, and they're all less than 90 degrees. We could have an obtuse triangle where one of the angles might be bigger than 90, so maybe it's something like that. Or we could have what's called a right triangle. And a right triangle has a right angle in it, or a 90-degree angle. So we won't necessarily be quizzing you or assessing you on that, but hopefully they sound familiar and we have had experience with that in the past. So in a triangle, we have three angles that are inside, and we call those interior angles. We also have quite a few angles that are called exterior angles, which are outside the triangle. So in the image below, we have 3 inside angles. 2 of them have numbers, 35 and 52. We could technically find that third one because we have a linear pair right here. So the outside triangles form linear pairs. This is not called an exterior angle because it doesn't make a linear pair, it's vertical. So we won't be using that as an exterior angle. But if we were to do the math really quick for this one, 180 minus 87 gives us 93 degrees. So this last angle inside is 93 degrees. And for our exterior angles, we have a couple spots that are outside. We call that the exterior. So this angle, this exterior angle would also be 87 degrees. This one way down here, we would do 180 minus 52 instead, which would give us 128 degrees, which means this exterior angle is also 128. And then over here, we would end up doing 180 minus 35 to get those exterior angles. So that would be 145. And both of those are 145. So we have our exterior angles, which are all outside of the triangle. And we also have our interior angles. And when I'm coloring these, it's not to show that they're congruent in any way. It's just to show the different colors. So interior angles and exterior angles. Let's take a look at those interior angles real quick. So if you want to go to this website, I think it would really help if you can play around with it. When we go here, we have a triangle right here. We know it's a triangle because there's 3 sides and 3 angles, and I can move these vertices to change what the triangle looks like. So if I go like this, I'm making the pink angle really big and the green and blue really small. But I could try to make it more equilateral. I could maybe try to make a right triangle depending on where I move these things. So you can mess around and see what you got. When you click slide me and you hover over that, it's going to put all of the angles together. So this one, they create a line. If I change the triangle around, maybe make it look a little different, it still creates a line. If I do a super bizarre triangle, it still makes a line. So think about, what do we know about lines? A straight line like that. In terms of the measurement, how do we measure the degree of a line? So it's a straight line. So it's 180. No matter how many times, how I move these triangles, how crazy the triangles look, it ends up making this straight dotted line that we can see. So my inside angles of a triangle equal 180 degrees. That is a theorem, the interior angle sum. All interior angles of a triangle add up to 180. And we can prove that using our last unit of parallel lines and transversals. So here's the image below. Our goal is to prove that the inside angle, so 1, 3, and 2, add up to 180. They give us that line AD is parallel to line BC. When I start my proof, I don't need to say triangle ABC with AD parallel to BC. It's kind of weird that they give that, but I'm not going to put that in my statement. I could. Oops. So AD is parallel to BC, and that's given. Looking at the image, remember, when I have parallel lines, chances are I'm going to try to use some form of angles with it. So let's highlight where those lines are parallel really quick. AD and BC. I have two transversals. So first, I have this one, which has angle 1 on it. Angle 1 is down here. And then it has this 3 and 5 all together, and it has angle 4. Well, 1 and 4 are alternate interior angles, so that makes them congruent. If I draw another transversal, that one right there, I have another set of alternate interior angles. Angle 2 is inside the parallel lines and on different sides with angle 5. So angles 1 and 5 are also congruent. Oops, 2 and 5, I'm sorry. And my reason is the alternate interior angle theorem. But I can just call it alternate interior angles for short. So since my end goal is to prove something with an equal sign, I'm going to go ahead and look back at statement number 2 and just switch them. So instead of angle 1 being congruent to angle 4, I'm going to say the measure of angle 1 equals the measure of angle 4. And instead of angle 2 is congruent to angle 5, I'm going to say the measure of 2 is equal to the measure of 5. And that's just my definition of congruence. So from here, I need to figure out something else to do. We were talking about how they make a straight line, which is 180. Well, I do have a straight line right here with 3 angles on it. So since those 3 angles are on a straight line, they've got to be supplementary. So I'll say that next. Angle 5, 3, and 4. And if you want to use your reason for this as definition of supplementary or linear pair postulate, definition of linear pair, all of those will kind of be accepted. This proof could be a lot longer if we were going to be a lot more formal with it. But we're just going to go quickly through it. So I'm going to use the linear pair postulate. So now I got that definition of supplementary. And whenever I have a vocab word like that, I'm probably going to use it for my next reason. Supplementary means they add to 180. And I'm going to use different colors for this now. So we had angle 4, angle 3, and angle 5 that are supplementary. So that means the measure of angle 5 plus the measure of angle 3 plus the measure of angle 4 equal 180. Well, if we remember way up at the top, we have already said things are equal to them. So we said that the measure of 2 equals the measure of 5. So I can replace this red one with the angle 2. Instead of angle 5, I can say the measure of angle 2. Measure of angle 3, I'm going to want to keep the same. Oops. I said I wanted to replace it with 2, but I accidentally wrote it as 5. My bad. And then the last one, we said that angle 4 and 1 were equal because they were alternate interior. So I have 2, 3, and 1, which matches what I have up here. 1, 2, 3 equals 180. 1, 2, 3 equals 180. The order is obviously not 100% the same, but we know that the adding order doesn't really matter. So we can still be at the end of our proof. And our reason, our very last reason, the only difference between steps 5 and 6 is that we substituted. So as a recap, our green angles were the same because they're alternate interior. Our red angles were the same because they are alternate interior. And our top 3 angles are 180 degrees because they're a straight line. Well, green, blue, and red equals 180. And since green, blue, and red are in the triangle, the inside angles of triangles also add up to 180. So let's practice some of this concept. First example asks for the measure of angle T, and they give us 2 angles already. Well, we are going to be using that magic number 180. So if I know 2 of them, I can just subtract them from 180. 180 minus 27 minus 82. I'm going to pull up my calculator for that. Did I click it? And that gives me 71 degrees. So the measure of angle T equals 71 degrees. And if I were to check that and put 71 right here, first of all, it looks okay because it's less than 90, but it looks like a pretty big angle. So I can check by just adding up my 3 angles and making sure they add up to 180. With this question now it's a little different. I could subtract 70 and 60 from 180 and know that that's going to be equal to whatever that number is. Or I can just set up one giant equation. So all 3 angles should add to 180. So 70 plus 60 plus 8x plus 2 should equal 180. So I'll just solve this like a regular old equation. I have a lot of stuff on the left side. So I'm going to go ahead and draw my line of balance. And I have so many numbers over here that I'm going to want to clean that up a bit. So I'm going to first look at the constants. My constants are numbers by themselves. So I have 70 and I have 60 and I have 2. So I will add all 3 of those numbers together, which gives me 132. And the only other term I have is this 8x, and I don't have any other x's to combine it with, so I'll just leave it by itself. Now I am left with a 2-step equation. I want x by itself, so I'll subtract 132 from both sides. That's going to let me cancel this out. So I'm left with 8x on the left, and 180 minus 32 is 48. And then this 8x shows multiplication, 8 times x. So to undo multiplying, I'm going to go ahead and divide on both sides, which cancels out my 8 and leaves me with x equals 48 divided by 8 is 6. So my final answer, x equals 6. If you need to pause to go back and look at that, you are more than welcome to. Ooh, this one's a different type of problem, but all 3 of those angles are inside, which means I have x plus x plus x equal to 180. I can combine like terms. So an x plus an x plus an x is 3x. And to undo that 3 in front, I'm going to have to divide on both sides. That gets rid of the 3, which leaves me with x equals 180 divided by 3 is 60. So all 3 of these angles are 60 degrees. And if they're all 60 degrees, that's going to make it an equilateral or equal angular triangle. All right, moving on to exterior angles. So in this situation, X is outside, but it's right next to this inside angle. Well, oops. We've done a problem similar to this with 70 and 60 inside, but we were solving for the other inside angle. So let's do that first. We can do 180 minus 70 minus 60. That gives me 50 degrees. So this angle right here is 50 degrees. And how I did that so quickly in my head is I knew that 70 and 60 combined was just 130. So when I want to solve for X now, I can make my little sun or my rainbow for supplementary, and they add up to 180. So to find angle X, I will do 180 minus 50, which equals 130, which means X equals 130 degrees. Well, look at the relationship of that. 130 degrees, and we subtracted it up here technically. So my 70 degrees plus my 60 degrees equals my outside angle. That's another triangle theorem. It's called the exterior angle sum. So the two non-adjacent just means not next to, so it's not next to angle H. Interior angles add up to the exterior angle. So in other words, this guy, the angle G and angle F on the inside, add up to the one that is not next to them, the outside angle, which is angle H. So if I were to draw another triangle that's similar, maybe something like this. Maybe I want to keep expanding some of it. If I were to find, let's say, this angle right here, I would want the other two inside angles that are not next to it. So maybe this one and this one. The blue angles add up to the outside angles. Or if I were to switch things around and I didn't want to use those, maybe I wanted to find this angle. Oops, not that one. This angle. In order to find that, I would need the inside angles that aren't next to it. So these two. We're going to do one example problem real quick, and then we are done. So my biggest way to remember, the best way to remember, in my opinion, is to say inside plus inside equals the outside. So if we follow that here, inside plus the inside equals the outside. And I know this angle right here is my outside angle. So to solve this equation, I want to get x on one side of the equal sign. I can move the x or the 2x. I'm going to move the 1 by itself, which leaves me with 70 equals x minus 5. And then I'll go ahead and add 5 to both sides. So x is 75. But the question doesn't ask for me to find x, even though I have to do that. It asks me to find all of the angles. So I have angle J right here, which is just x degrees. So I know that that's 75 degrees. I already knew angle L is 70. And I have two ways to find the other one. I could do 180 minus those. So 180 minus 75 minus 70 is going to give me that angle right there. So 35 degrees. And I can't name this angle K because there's a couple pieces on angle K. So I'm going to go ahead and name it. I'll use a yellow. From here to here to here is L to K to J. So with my little fancy camera, from L to K to J is that angle that I'm tracing, or J to K to L, as long as K is in the middle. So L, K, J is 35 degrees. If I wanted to find that exterior angle, I know it doesn't ask me to, but the measure of angle MKJ is 2x minus 5. So I know that x is 75. So I just plug in 75. And I can plug that all in on my calculator. 2 times 75 minus 5. Ooh, I did negative 5. I'm sorry. 2 times 75. Oh, dang it. Minus 5 is 145. I knew I made a mistake on my calculator because it doesn't make any sense to have a negative angle or an angle that's bigger than 360. So I knew that answer didn't make sense. So the measure of MKJ is 145 degrees, which should match up the 70 plus x, 70 plus 75. All right, that is all for today. Have an amazing day. Go work on your homework.